right, so one of the last ways for us to figure out how many roots a quadratic equation has is to use something called the discriminant. In our second lesson, we're going to talk about the quadratic formula, and the discriminant is a part of the quadratic formula. It will tell us how many solutions we have, not what the actual solutions are. So let's recap a couple things that we've talked about. We've talked about lots of ways to solve a quadratic equation and find those roots. They included factoring with our cross puzzle, square root method, completing the square. We'll talk about quadratic formula in the next lesson. And each one has advantages and disadvantages. So if I look at these different examples, I would probably start first with my cross puzzle. And I could say here that I would get, -3 and +8. And I could use my grouping -3x -24. And when I do that, I can factor out an x, I can factor out a -3, and I get my factors of x minus 3 and x plus 8. So I know that I would have two roots here, which would happen to be -8 and +3. If I wanted to, this next one, cross puzzle obviously won't work. Maybe we did completing the square, and maybe I got x squared minus 6x blank equals -2 plus blank, and I could say -6 divided by 2 is -3 squared is 9, and I could say x minus 3 squared equals 7. I could take the square root on both sides and add 3, so I would get x equals 3 plus or minus the square root of 7. And again, I would see that I have two roots. Maybe on D, I would just do the square root method, and I could say x squared equals 100 and take the square root on both sides. I could say x is plus or minus 10, and again, we have two roots. So we've talked about lots and lots of different ways to do this. How would you decide? I would, you're looking at a couple of different things, factor is the easiest way. I would look to see if I could factor first. On letter D, there was a squared, so maybe, square root or complete the square. It kind of depends on your preference. So today we're going to look at how exactly you can decide very quickly how many roots there would be. So here we have the expression, the square root of b squared minus 4ac. Now, the quadratic equation or formula, again, we'll talk about that. This is actually a part of the quadratic formula, this b squared minus 4ac, and that's the only part we're going to worry about right now. And it gives us information about the number of real solutions as well as the number of x, which is the number of x-intercepts that a quadratic would have. So remember, we still have a is 1 on this example, b is 2, and c is -8. And we're going to simply plug that in into b squared minus 4ac. So I'm going to say 2 squared minus 4 times 1 times -8. So I would get 4 plus 32 is 36. Now, because we got a positive number, we will have two real solutions and two x-intercepts. We're not actually worried about solutions here. If I was to graph that, I know it would have a y-intercept at -8. We could graph it in our calculator to double check. But I could also go through, if I wanted to, I could find vertex and such. We're not going to worry about that right now. We are only worried about the number of solutions. On this second example, a is 1, b is 2, and c is 1. So if I do again, b squared minus 4 times 1 times 1, I'm going to get 0. Well, I know from square rooting, from our square root method, that if I get 0, that means I only have one solution. And this one is actually going to, if I graphed it, I could see that. And then finally, A is 1, B is 2, and C is 5. So 4 minus 1, 4, B squared minus 4A and C. Well, here I have 4 minus 20, which is a negative 16. And we know that that is not going to be possible. So this is going to be a 0. This one is going to cross way up here and go up like this. If we wanted to, we could double check those roots. Again, we're only worried about that, so I could go to my calculator and I could look at my graph. Our first one was x squared plus 2x minus 8. And I can see, in fact, that there are 2 roots there. My second equation, x squared plus 2x plus 1, I have just the 1, and it is also the vertex. And then our last one was x squared plus 2x plus 5. Helps if I hit tab. Plus 2x plus 5. You can see that is way up above the x-axis, so there were no roots. So what we need to take from this is that if we're doing b squared minus 4ac and we get a number greater than 0, so if we get a positive answer, then that equation will have 2 real solutions and 2 x-intercepts. But if we get exactly 0, we will have 1 solution or 1 x-intercept. And if it is a negative number or it is less than 0, we will have none. So very much like when we did the x squareds and the number of solutions. So if I come down here to my check for understanding, just for practice, so I'm going to do number 5. So A is 4, B is 2, C is negative 12, and again we're putting this into b squared minus 4 times a times c, and you can definitely use your calculator if you want. So 2 squared is 4 minus 4 times a negative 12. So we can come over here. 4 minus 4 times 4, what did we just write? I forgot already. Negative 4, 4, and negative 12. 4 minus 4 times negative 12 is 196, so it's a positive. So that means that there are going to be 2 solutions, or 2 roots. On number 6, b squared, so I can say negative 7 squared. Remember, if you put that in the calculator and you need a parentheses, minus 4 times 1 times 14. So 49 minus 4 times 1 times 14 is a negative 7. So we know that that means this will have no roots or no solutions. Just like we can't take the square root of a negative. On number 7, b squared, so negative 10 squared minus 4 times 1 times 25, 100 minus 100 is 0. So this is going to have 1 root. Sorry, no S on it. Please let me know if you have any